Hey, hello to AUTOMAT Live-Coding. This is the stream where we write AUTOMAT, the application for automating desktop with smaller toys that can be connected together. Here is how it looks like. This is a test case. This is actually a benchmark for how good we are at rendering. Recently, we switched to a different rendering backend, which broke all of our fancy cable shaders. So we have to fix that now. It's good that we switched right now, because we didn't write too much code still. So it should be fairly easy for us to fix everything. Yeah, I did work on the geometry, like the tessellation for the cable, so we have a slightly different way to tessellate this plug. I think it's decent. I think if we connect it to the rubber shader, it will look nice. The reason we see the gradient, this is a UV map essentially. The red channel contains the U coordinate, the green channel contains the V. Yeah, fairly simple. And when it compacts fully, we get this nice squeezed UV map, which I like very much. When we zoom in, we see the tessellation artifacts, but they are very subtle. Okay, so today we will try to bring the shaders from this build here, so that at the end it should look just like that. So this is how it used to look before. Yeah, I think the shape that we used to have was much nicer. Oh well, we will see. We'll do a test. Soon. Okay, let's start maybe with hopefully easy case. Let's start with shading the metal thingy here. Right? The way we do the shading is we have a fairly elaborate shader that does all of that. This is not a texture, this is a shader. So it will react to different, for example, positions that it can be plugged in. So if I record something, right? When it's connected from this side, it's shaded slightly differently because the light shines from the top here. And again, light shines from the top, and still light shines from the top. Oops. Anyway. So let's get started. First, let's find the place where we do the black casing. Okay, this is it. So this is the new code, and the old code is here. This is our shader. Fairly complex, I would say. Okay, we're actually using light direction here. But I guess for us, the light is always going to come up from the top. I'm just not sure if we have access to the pixel coordinates in the shader. We will see. Okay, there is one thing I wanted to try. It's whether the live mode still works, because live mode is super useful for interactive development. If I pin this so that it's always on top, zoom it here, then I should be able to just change a piece of code, for example here, save it, and that should rebuild and restart AUTOMAT. Okay, it did. It's just we didn't save the state. Okay, so maybe I will zoom in, close it. Okay. I don't think we successfully stored or on the Windows state. Yeah, we say always on top true, but when we run AUTOMAT, okay, now it is always on top. Nice. We can also resize the window. It's printing some error messages, but really it's still saving stuff correctly, so that's not a problem. Okay, so we can do almost interactive debugging. It's not perfect because it still is focus, but we can work with that. Okay, how do we do shaders? So since we wrote this original code, we changed some things. So now we have assets directory, and here we create those SKSL files. So let's do, how should we call this? Okay. We can see how other shaders are structured. Some of them have a bunch of uniforms. Okay, this is our runtime effect. This is how it's called. Now we have a paint. I think the way we create runtime shaders is slightly different. Let's see how we use that. So first we create something like that. Okay, this is the thing that will allow us to connect uniforms. Cool. Okay, we are compiling and we end up with a red thingy, so I guess it's working. I can remove this set color. Nice. So now the color is calculated here. So we have this UV. Okay, we are watching the src directory. And really we would like to watch two directories. Let's do this. Now we should be able to watch multiple directories, and yeah, we'll pass assets here. This is a really nice gradient. So Skia is probably doing sRGB conversion for us. This doesn't seem like pure red. We're using this this screen blend mode. But this only specifies how we blend between vertex colors, okay, and the stuff from the shader. We want to get rid of these colors. Or not, or not. Okay, so this UV contains the texture coordinate. Let's try to bring our original code. And this is the shader. The actual one.
Knight says,
Hey everyone!
Hey, Knight. Cool. Those are the errors. Very weird. Okay, we are getting those errors. For example, v is undefined, probably because we are not using our varings. Okay, so instead of v.uv, we can just use our own uv. That one is simple. Let's do something like that for now. Look at that. It really wasn't much work. It just started to work. This is pretty surprising. But it was so easy to blend this. Okay, the cable looks fairly grayish. I think this is because we are using tint, like the screen color blend. Let's not use them for now. Let's stick to tint the way we used to do it. Let's disable colors. This screen is totally unused. We will set the color filter. We are almost back. So the thing is, this light value, it used to be 1 around the top of the connector and 0 near the bottom. We don't quite have the pixel coordinates here. I'm sure we can recover this. Just need to see what stuff is available in SKSL. I'm afraid we don't have the FDX. I think I went through this already. Maybe we need to pass a single value. Maybe we need to enforce the shader version. This seems to be a private API, unfortunately. So we have those functions. Okay, we have escape position. This uniform is not initialized. Maybe escape frag chord. This doesn't seem to work. This line seems to just be like ignored. Okay, we can specify options. Or maybe this is private. Yeah, it seems to be private. Or maybe there is a chance. I mean, it's just a flat structure. So we could do aliasing and set a different values ourselves. I don't think I can refer to that. So of most of those. Now we can pass our own options when creating a scale shader. So we could increase diversion. And it works. we can use derivatives now. Okay, so now that we have the derivative, this alpha can be misleading, so let's get rid of that. Yeah, it's just the alpha being an issue. The derivative is definitely calculated. Now, how can we actually use this to find the, like, how far we are?
For cable shading, you can check this. Link sent via email.toi.
Yeah, it's a nice reference. I think we will get a similar effect. It's just about figuring out who make the math work. I need to draw some pictures, as usual. So, there is some rectangle. This is our connector. And it can be rotated. So we have two coordinates. We have U, which goes like that, and V, which goes like that. We also have screen coordinates. This will be X, and Y. Sorry, Y will go like that.
There are examples of connector shading at the bottom of the page.
Oh yeah, those things. Yeah, they are nice. Unless you are referring to something else. Really cool images. This is definitely the aesthetics that we are going for. Like natural stuff that imitates like normal connectors. Like audio jack or HDMI. Okay, I think I know what we should do. I think we need dfdy UV.
These images are normally called vectors and are similar to the models in AUTOMAT 3D objects.
Yeah, and we are perfectly positioned to draw them like ideally. Like we are using the same approach for rendering as the authors, as the vector drawing software here. So we will be able to have really nice images. We are not using like 3D with triangles and stuff. We are using exactly this rendering approach. I also like the ports. I think it would be nice if like the video connector or the audio connector, if they actually looked like correct audio ports. And color coding. Yeah, color coding the same as for as is used in the audio industry. Okay, I am trying to figure out how do we apply vertical shade, vertical gradient. This is what I want. So when we do that, actually, what is this color? The stuff that we have here is that.
Will there be shading depending on the connector angle? Then the light needs to be fixed somewhere in the program.
Exactly. We can do this in the shader without passing any uniforms. So the shader should be able to figure out the direction of the light, because the light always comes from the top. This is the assumption we are making. In the whole user interface, like the top light just makes it consistent. One strange thing I'm getting is the... Why am I getting red component? That high. So no, something like that. to disable color filter because it's messing with the values that I'm seeing. Okay. Now we are getting this value, which is good. Because it means that the red component is 0, the other is -1. I think we should dot this with UV right now. Okay, and we are getting this shade from the top. Let's copy these to other channels. Is happening here? So we have those three cases. It seems we are working correctly in those two, but not in this one. Let's do something like that. Let's do, before we draw, save, restore. I specify the position. Yes, I can. Accelerate this. Okay, I think we need to rescale UV. It shouldn't be from 0 to 1. The center of the UV should kind of be in the center of the rectangle. Now we have a symmetric thingy. Now we can divide the result by 2. Remove this +1. Okay, we have a nice shade. It's going in the opposite direction, but it's not an issue. We can just put a minus here, or anywhere really. Pretty cool. Remove that. Cool. Now the connector is lit from the top, so it's brighter on the top and darker at the bottom. Nice. Now we can remove our rotation, debug rotation. Okay, so things are in place and we can bring back the color filter. Cool. There is one more thing that we are missing, this. So we have a uniform called plug with pixels. This is used for anti-aliasing and transparency. So when I specify some value here, it should cause the border here to become transparent. Doesn't seem to work. I'm not sure what is bevel. Let's visualize it. I don't think we need this radius pixels or whatever. It's a little strange to me that bevel doesn't seem to reach through white. Okay, maybe it's because of the color filter again. Yeah, it's messing up with shading. So annoying. Oh yeah, now it's very well behaved. So we should generally make it transparent. Oh, I see. If we want to get anti-aliasing, we need this trick here. Honestly, it looks like it should just work. Okay, there is transparency. I don't know why we didn't have it. Maybe it's because of the color filter? It would be strange. Oh, it was because of the color filter. Okay, I want to store this gradient because we should be able to use that to compute the size of the connector. I think this should be right. Yeah, it's super smooth. When I zoom in too closely, we see individual pixels, but even then we see a very subtle anti-aliasing. Nice, really nice. Okay, this is really mind-bending, but it's hard for me to think about those gradients, but they work. this is something that we would normally have to pass through uniforms. Okay, let's think about the tinting issue now. So enabling color filter messes up the shape. The old code we can probably delete some more than 100 lines of code that we can throw away. Nice. Okay, this A of I should be I. We just messed up our color filter thingy. Now it should preserve the alpha value. So we fixed the bug. Okay, so that was the first shader out of the way. 3 more to go. Maybe we could do rubber next. It's very visible. It's so nice that we fixed this. I didn't even notice that we lost transparency in corners. That's nice. Look at how much smaller the code is now. That we moved the hard part into a separate file. I think there is one more thing we could do. Those shaders, I think we could retain them. Okay, I should be able to pass null pointers everywhere. I don't need this builder. I wonder whether we can have a weak pointer. I don't think we can. For Skia stuff. So I'm looking at this code because I'm thinking that maybe we could build those vertices once and store them in some global scope. And the same for shader. Okay, that was our black casing. The next thing we will do is let's actually copy all of that. This will be useful. And the options hack, we can actually move out. Or maybe not, maybe not. So this is the icon and this is the rubber thingy. And this one is slightly harder to render because we have to generate this mesh.
Ebon says,
Hello, where are you from?
Hey, I'm from Poland. Okay, we are getting rid of this paint. It was fun, but we don't need it. So I'm passing the same shader as for the metal casing, which is going to look weird. Yeah. Weird but interesting. So theoretically this shader is supposed to look like metal. It doesn't look a lot like metal to me. Anyway, we had those colors. They were just for debugging. We can remove them. Yeah, and now we get nothing. I wonder why. Why is it empty now? I have no clue. I think this is the shader's fault, because when I disable shader, the cable appears. Like the sleeve appears. Okay, let's create a new shader for the cable, for the rubber part. Can copy this stuff verbatim. Should just work. Look at that, we are not passing texture coordinates. This is why we are not drawing anything. It thinks... yeah, the coordinates are messed up. Let's pass them. Yeah, now we are getting something. It's totally broken, but it's because we are using different shader. You can see that there is our old shader, it's kind of wrapped around the surface of the cable. And here are just like weird things are happening here. Okay, let's grab the code for the old shader and copy it over. Where is it? This is it. looks complex. We have a bunch of issues. Mostly about using the mesh API, which we can fix very easily. Although not all of them. Okay, I think almost everything here will work. We just need to figure out how to compute the tangent. Okay, the z component is always 0 because the tangent is always, it goes along the surface. So tangent is the, it's the tangent, right? I wonder. I think this will be one of the df(dx) or df(dy). Wow, that was fast. In some cases it seems to work, but not in all of them. There is only this situation here, where the cable is almost straight down, where we seem to be messing up things. Why is this happening? UV should be smoothly interpolated, but it doesn't seem to be smoothly interpolated. It looks very glitchy. Let's look at the tangent itself. Okay, we are messing something up. It should not be looking like that. So good. That's a mistake in our code. So here, this is the direction of the y, of uv.y. Okay, that makes kind of sense actually. So now it's going down, so it's very red. When it's going right, it's very green. Can show it like that. this doesn't seem right because it's changing along the radius, along the this dimension. It should be constant here. Change those two values, definitely. Okay, there is a small issue here. I see. uv.x contains this offset here. So I remove that. Okay, slowly starting to look better. I need to measure some colors. Strange, but so when it's going up, we are getting this. Let's query some more colors. So when it's going right, it looks like that. Okay, so this translates to -1, 0. Let's probably... Oh, it crashed. The value when it's going... Sorry, that was left. So when it's going right, we are getting this. This is 1, 0. Okay, looks looking good. And now, when it's going up,
Tyrannical Emperor says,
Hi.
hi.
What are you doing?
I'm trying to debug the... I'm writing shaders, essentially, for stuff that's supposed to imitate rubber. Right now I'm debugging some of the vectors, so this is how you debug shaders. You cannot really print stuff, you cannot really use a proper debugger. the only way is to display funky textures with some extra information. So here the R and G channels show the direction of the tangent of the rubber surface. So when it's red, it means it's going right.
Can I ask what your channel is about?
So we are making this application here that's meant for desktop automation. It's a small app, maybe not so small. It's about 10 megabytes. Anyway, it's a small application that can send fake input into games so that it's like AutoHotkey. If you have some repetitive action like grinding gold or experience in games, you can record macros and AUTOMAT is going to play them back. And if I'm not wrong, we should have fixed it. So is it working? Yeah, it is. We have a decent rubber. Yeah, it feels like it's slightly... I think I see triangles, but they are dynamic, so they disappear when I zoom in. Or I can still see them, kind of. Anyway, looks like this stuff is working. Even this case is producing some reasonable result.
That's cool. I wonder what courses and lessons did you do to get to that level?
I actually didn't, so I went to computer science university, but graphics is a hobby. I think it's much nicer to have as a hobby than to study it. Because when you have to study it, it becomes your responsibility. It's something you have to do. And if it's something you do for fun, it's not as exhausting, I guess.
How languages did you know?
I'm not counting. You mean programming languages or human languages, natural languages? Look at that, we have our edges working again.
Sorry, how many programming languages do you know?
Quite a lot. Usually I mostly use Python for almost everything, or JavaScript. But it depends on what I want to do. Programming languages are very similar. Once you learn one of them, it's very easy to learn the next one. Okay, I can show the old cable holders, the stuff that we had before I broke the code. So this is how the new ones look, and this is how they used to look before.
Which language did you start with? And how long did it take you to learn it?
So when I was learning programming, the programming languages were slightly less capable, so I think it was easier to learn back then. So I started with how they are called. Not this. This, like command prompt for Windows. Yeah, so nowadays it's slightly different. So I started in a very imperative fashion, because in this language you kind of basically don't use variables. The variables are an advanced feature of this language. And don't even mention loops. Like it's... This stuff is the command prompt that I used to learn. It's so basic. Okay, I don't think there is a large difference between our code here and what we used to have. I think Skia does a very good job, much better than we did at Tessellation. There is a small difference in shape.
I'm actually interested in learning coding, but I don't know where to start or how to improve in my designs for what I make.
It's good to do stuff like advent of coding or advent of code. Especially nowadays, you know, it's December, so you can open this page, go to 1st January, and they give you small toy problems. Initially, they will be hard to implement. Initially, it will take you like half a day to do one of them, and the ones which are like further down, they will be impossible. But when you spend some time on each of them and struggle a little bit, you have to struggle. It's a critical component of learning. I think this is the best way to get better at programming. Just, you know, pure programming, not talking about any specific application like graphics or music. So this teaches data structures and algorithms. I really like the old shape. I don't like the new one. So when the cable is straight, there is no difference. But when it's twisted, there is.
How did you put shape and dimensions to the cables?
So what I'm doing is, when I have a cable, I know the position where the cable connects to the object. From this position I take offsets. So when I move right and top, I can get the top right corner, and so on. When it comes to this cable here, getting the bottom corners is fairly easy because I can get them just by taking a known offset from the point where the cable is attached. But to get the top position, I have to walk along this curve. There is this curvy line for the cable. And I walk for 1.5 centimeter. I mean, this is in metric units, so there are centimeters here. When I get to the end, I go to the right. I know the direction where I'm going, so I can turn right, go 1.5 millimeter, turn left, go 1.5 millimeter, and this gives me the positions of the top corners of the cable. And between the points, I follow the Bezier curves. Bezier curves are probably the easiest and also smooth, easy, numerically, mathematically they are simple. So it's very easy to iterate from one point to the other along a nice curvy path. You just need to know the points where you are and some control points, and that's enough. Right now I wanted to try that. This is a very squarey shape. It's not bad. I think I just need to multiply this by 0.5. And now I'm just playing with the shape, so not doing any useful work. Okay, I think the new shape is looking nicer. How does it compare with the old one? Okay, I think I like the new shape.
It is 90s similar drywall.
Yeah, almost indistinguishable, I guess. So before I used to generate this shape completely differently. I used to walk along the line and I was generating a strip of triangles. You can even see them if you look very closely, because there are those sideways lines going through the geometry. In the new version, they are slightly less visible. When I unzoom, in the new approach, there is actually a proper tessellation. So when I zoom in, there are more triangles. When I zoom out, there is less of them. And there is less artifacts here at the bottom.
Is the screen on the left the design, and on the right, the app?
So this is, I'm doing a migration to a different rendering library, kind of. I mean, the same library, but a slightly different backend. So when I did that, it's kind of the same application, it's just rendered differently. So in the old version, you can see the FPS numbers are kind of insane, because I didn't have a way to limit FPS, and in the new version, it's much more reasonable. It still feels nice. Anyway, the shaders that I wrote for the old version broke, so I'm just fixing the old shaders today. And we just finished the second one, so the rubber holder. So this is done. Okay, the next most visible one is definitely the braided cable. So let's take care of this one. Before we do that, we can delete the old code because we don't need it anymore. Yep. From here to here. Cool, it's still working. Okay, maybe I will change one more thing. I don't want this to be so curvy. Slightly less, please. Okay, nicer. And we can delete the shader because we had this. Nice. I don't know if it's a good thing, but I like that we don't use any uniforms. 0 uniforms. We are just using those like black magic functions. Anyway. The next one on the list is this one, draw cable.
What program are you using? May I ask what is a shaders? And also, what did you mean by uniforms?
So the stuff that you're asking is kind of, I think, better explained in proper books or like courses online. I can mention this. So when drawing stuff using a GPU, you tell the GPU the kind of coordinates of a triangle that you want to draw. The GPUs can only draw triangles. They are like specialized in that. And when they fill the triangle, the GPU, for every pixel that it fills, a pixel is called fragment by GPU. It's just a name that they use internally. So for every pixel that it processes, it will run a very small program for you. And this program is called shader. And you can specify how do you want to compute the color of the pixel on the triangle. So this will be executed for every pixel that is being drawn on screen. This program, it has a main. It takes the coordinates of the pixel which is being rendered, and it should return a color as 4 values, RGB and alpha. Yeah, basically. This is kind of a sport. Or maybe not sport. It's a really nice pastime, writing shaders. There is a website called Shader Toy that I really like. And should be a way to browse recent shaders. Yeah. Browse. So you can check some ideas about what people come up, what can be drawn. People like to encode like the whole worlds into shaders. So there are some crazy shaders that render, for example, stuff like that. So there is a program which is evaluated for each pixel, and for each pixel it kind of renders the whole scene. A lot of cool effects can be achieved using those small programs. This is a nice one.
What other websites could you recommend?
For writing shaders, actually there are some better tools probably than Shader Toy. I'm not following the latest tools. I know there are some like desktop environments for writing shaders. Blender would probably be nice. I don't think you can write shaders directly in Blender, but Blender has something very, very similar. Or Unity or Unreal, I think they also have sort of... They have a like node-based environment for writing shaders by connecting blocks. So honestly, I haven't been doing teaching in a long time, so you'll probably be better off by checking some online courses. This sounds interesting, neural cut. I guess there is some neural network generating the image. I want to see how it looks.
Well, I gotta go somewhere.
Sure. See you around.
Nice meeting you.
You too. See you around. Okay, this is an actual neural network. It was probably taught to generate this image. Okay, this looks strange because this looks like a convolutional neural network. For encoding something like an image of a cat, I think something like LBF. Yeah, this kind of network would be better, and a flat one, not deep one. Nice idea. Okay, so next we will do the braided cable shader, this part. But first I will grab some food. So maybe 20-minute break. And I think AUTOMAT is stable enough to show the timer now. Okay, so see you in 20 minutes. I noticed some weird transparency artifacts on the toolbar, of course. Crush. It doesn't matter. Okay, this is our mesh specification. This is the program that we use for shading. It's not complex, so hopefully, fingers crossed, we should be able to convert it easily.
Andrakuma says,
Hello.
Hey, let's put a comment here that it's a shader. And it should return float 4. It takes fact to UV. Okay, we have tangents, but we know how to do tangents now. This is not a mystery anymore. Okay, I think we just need this T here, and I think we can steal it from the other file. Like that. This is our paint. Where was I? Draw cable. Okay, now we are drawing the cable out of a bunch of smaller primitives. We have those patches and points. So we have to define our paint before we do any drawing. Paint is redefined. Is it? I see. Okay, now this shader is actually going to use a child pointer, I mean texture. Actually two textures, cable normal and cable color. We also have cable width, which we should actually be able to compute ourselves. Okay, this UVX tells us where the x coordinate is going. It ranges from -1 to 1. So cable width is going to be 2 divided by length of this thingy, I think. Yeah. Okay, we need 2 subshaders. Look at that. Can I use that? I don't want to delete too much stuff. I can't use this children, it needs to be just a pointer to SKSP. Now we should see a crash. This should be the compilation issue for cable shader. Okay. It has no right to work. Strange. Oh yeah, I was doing something funny here. I was multiplying this by 400. It's not looking great, but it's also seemingly compiling. Let's try UV. Oh, this is the wrong shader. I don't want to change anything here. Yeah, and I need to change the shader to okay, now it should fail the compilation. Thank you. And now the cable should start from completely no green to like fully green at 10 centimeters approximately. And horizontally there should be a gradient from black to red. Seems it's there, but here, maybe because of the tint filter, yeah, that could be it. Yeah, now it looks better. So we have U and V. So I wonder, shouldn't it work? Just work? Almost. I think we should scale the length somehow. So we are clearly sampling from the cable texture. This text chord. This is the horizontal coordinate. This is the vertical one. It would be nice to know. What is the cable width? Because if we messed this up, should be a very large value, so we can divide this by, let's say, 100. So now, when the cable is 100 pixels wide, it should turn white. Okay, now, this could be 100 pixels. I can believe that. Or here. Actually, this is looking fine. Now let's go for 500. I'm just seeing if the scaling is right. And yeah, it seems right. It gets white right around this width. And this is around 500 pixels. So it seems we are getting cable width correctly. We also know that uv.y, I think I know. uv.y is using local coordinates. We need to know this is the meters and this is pixels. It's like converting inches, imperial units and metric. I think we need something similar, but with av.y, and we can fix those coordinates. Check this out, we have a proper texture mapping, suddenly. Well, maybe not everywhere. Huh. So weird. And this is triangle strip. Now it's just as bad. I'm just trying random things. Using derivatives to find the texture offset. Derivatives are very noisy, as you can see. They often make numerical errors. And I think we are amplifying this error. It definitely looks interesting. Okay. We will remove this funky normalization. We can try to scale it like that and see if the error goes away. If the error goes away, then it means it was due to numerical errors, not our mistake. I think we should be multiplying this. Now, depending on the zoom level, get funny issues. Okay, so that was the issue. That was just unstable numerically. I think the error with this one was if we could see behind the rubber thingy, the error here would be lower, and it would probably increase with distance. Anyway, we can fix that by applying the scale from the canvas matrix. And whenever we store length, we'll store length times scale. Now we can zoom in and out. Oh, this is so jagged. It's because of the tessellation. Looks decent here, but not anywhere else. You can almost see the triangles. They cause very subtle bends in the texture. I guess it's fine. Let's see how it looks with the tint. Not bad. Let's look at the original. So this is how it used to work, and this is how it works now. I don't see a difference. I can record some keys. So that you can see how it looks here. Okay, it used to be broken as well. So it's not a new thing. Yeah, same thing. Same shader really, so why would we see any difference? Except now we use less uniforms. Because we found tricks, hacks, that allow us to access hidden features. I am a little bit worried about using this, but the worst case is we can pass this information through a uniform. Okay, let's get rid of the old stuff. So this is our loop, and this is the lambda that gets the width. And this is the old approach. And this we want to keep. We don't need to do that because Skia should be doing this for us. Okay, here I could actually simplify some of this code. First of all, start offset. This is not really used anywhere. Let's get rid of that. Okay, so this we kind of need to know where the cable ends, and we don't want to walk along the path twice. So we should call this cached length. Let's say it's 10 centimeters. We cannot combine them. Unless I capture the same stuff. Can I do this now? Why are they incompatible? It doesn't make sense.
Kernstein says.
Lambus are entirely different anonymous types. If they don't capture anything, I think they can be implicitly converted to function pointer, which may be compatible. You'd have to pass captured variables as arguments.
I could. Okay, that was just to save like 1 or 2 lines, but yeah, when I drop stuff from here, this becomes a function pointer. And I could pass, yeah, like here. Yeah.
This TTS has character.
And this is, I think, the voice of orcs from Warcraft 2. They had pretty good voice actors.
Haha, that is Isendal.
Anyway, I will just clean the code before I submit. I like to do a final pass to say not submit garbage, but philosophically I don't really care about what's within the function as long as the function signature makes sense. Oh. Okay, we have a really nice shader now. I mean, we used to have a nice shader, but we still have it. We restored it. Okay, I just fixed this. I wanted to see if the rubber shader, yeah, the rubber also works. Okay, looking at our roadmap, for today we have just this one. We still want to fix the shader for this gray part. It shouldn't be just a gray rectangle, it should actually look like a piece of steel. And yeah, that will mark the end of the graphite switch. Okay, let's get this out of the way. Here we have a section which draws the steel insert part. Somewhere here we have the fragment shader. I will just drop this into a new file, same as with all the others. And this shader works differently. This takes just UV and it returns a color. And I think this should be enough. I mean, in terms of shader code, even the validator doesn't see any issues. And the validator is overly pedantic. Like, it tells us we don't have access to those functions, even though we do. So here, we do have paint. Let's fold this. Instead of setting the color, and it's black. There is something nice about this black part here, but this is not what we were going for. So let's try to see what's going on. Okay, UVs. definitely pass them. It shouldn't be completely black. Okay, so the error must be here in C++ code. Okay, there will be some looking, trying to figure out what's wrong, but this is the last thing that we are going to do today. After that, we will think about what next. We will keep improving the rendering pipeline. I want to bring as many features as I can until end of December, and next year we are kicking off with some big new feature. Something like a built-in Python terminal or this assembly environment.
Our Kearns just followed on Twitch.
Hey, thanks for the follow. It's nice to find people on Twitch, I mean from your comment, that don't seek just gaming. And who can actually chime in with useful kind of tips. This is totally crazy. We are returning pure white. We actually don't need hack here. Or maybe we do. Yeah, we have this uniform. Yeah, and that was causing the issues.
Agreed. People that actually do graphics programming is pretty rare on Twitch. Always to find one. Built-in replit terminal sounds very fun.
this built-in environment. I haven't still decided which one, but it kind of brings the project in a totally... I mean, it's the direction I wanted to go in originally, but to make it more of a, like a visual programming environment. I still feel that we are missing some key features about, like, desktop automation. For example, editing the timeline is super annoying. If I want to manipulate multiple objects at once, I cannot, because we cannot have this concept of selection. So we're still missing some key things, but I think we'll be fine. We can have fun and insert fun features, not necessarily just desktop automation. Okay, so here we are using this plug with pixels to add some transparency. Isn't this nice? Basically works right out of the box. But we wanted to make this corner rounded. And for this, we need to estimate, we need to know how large is the pixel in local coordinates.
Taste my steel for Doomhammer.
I think we can copy paste this. This should work. Yeah, and there we go. It's rounded. I think it's slightly too blurry here. I can also do that. I don't need any length computation now. But this is too sharp. You know what? I will just bring the previous version back. Oops. Yeah, it's fine. We don't have to be like, it's not even pixel perfect, because normally this is the normal scale. So the stuff that we are adding is totally, it's almost invisible. Only when we zoom extremely closely, it appears. Cool. So this is it. Those are all the shaders fixed. We are using the new Vulkan-based rendering middleware. I can remove the old stuff, like this mesh thingy. happened here? Can we delete that? What is the issue now? I can delete more stuff. I think this stroke to mesh can also delete. And this, yeah, hundreds of lines of code. So if I take a look at the Git log, I'm not sure if you can see this, but we removed like a ton of code related to the old rendering approach. Okay, so the next step, we fixed this. So the switch to graphite is kind of complete. We could try running the test, the event delivery test, because the whole point of switching to graphite was to decouple the main UI thread from the rendering thread, so that the latency of event delivery and event. So when we receive events from the operating system, we want to receive them as quickly as possible without even a millisecond of latency. And now this should be the case. We can verify this by running our benchmark. Event bench, this is how it's called. So AUTOMAT will probably crash while running this benchmark, but before crashing it should record everything that it should record. Okay, we have to recompile Skia, apparently. It will take a moment. I'm not touching that. This is like too much work for me. And I think we'll rewrite all of those widgets as we go on. Okay, this seems like a simple small task. So this will be the startup task for the next stream, and there is something which I don't see here that I think we need to do. It's that we are rendering stuff in multiple threads, but when we delete an object that is currently being rendered, it causes like null pointer dereference, or like bad memory access. So we need to fix the data race when between render and main threads. Okay, this is longish text, but this is because this is actually a complicated issue. So this is going to be probably the next stream. So next stream, unfortunately, we will not be writing many shaders, but yeah, we will be fixing concurrency issues. They have to be fixed when we do this. Even the networked rendering will benefit from this. And the compilation is slowly crawling to the end. Okay, I shouldn't move the mouse. Sorry, what? I wanted to run the test. Okay. We don't really see where the error is happening. Okay, but this is probably a good... Let's mark this as done. Yay! This is probably a good thing to do on the next stream. So check the segmentation fault. It's very likely that the GitHub build will fail. I mean, it will not fail, it will work, but it will be a non-functional version. Yeah. Oh well, we'll fix this soon. So we'll do some more graphics optimization and then, yeah, big new project. We'll see which one. Okay, so this is it for today. See you on the next stream. Bye.